Hi everyone, this week in Level E we're going to be covering lessons 125 through 128. You will need worksheets 97 through 100, the practice sheet 14, your geometric solids, the safety compass, a ruler or straight edge of some kind, the drawing board, T-square and 45-45 angle triangle, colored pencils, the geoboard with rubber bands, the math card games book, the corners, multiplication, and basic number cards. There is a correction for lesson 125. So if your book was printed before March 10th of 2017, please follow the link in the description to find the correction. In this lesson, we will identify solids from their views. The warm-up is the first multivide on practice sheet 14. Give your student the geometric solids and have him or her identify the figure when you state the name. You will then draw the three views of a square prism and have your child name the prism. So let's take a look at the first three examples.
So before we go to the drawing, I wanted to go over the step-by-step process that we use to help the child identify a particular shape. This is called a three-step process. So the first step is I name the shape and your student identifies it. So if I say a square prism, your student looks at this and says, okay, that's a square prism. If I say a sphere, they identify this as the sphere. The next step is to say, okay, what is this? This is a pyramid. What is this? It's a cube. So then the third step in this process is to remove these, and I'm going to draw the views of a particular shape. So for example, if I draw this, and this, and this, your student should be able to say that is a square prism, because this would be the top view, a square, and then the two side views. They happen to be the same, but that's what helps the student identify the shape. You need the three views. So the next shape I'm going to draw is kind of funny because all three views are the same. And that is obviously the sphere. It could also be the hemisphere, the half circle, could also form these views.
All right, so after going through those first few examples, have your student complete the worksheet and answer the in conclusion questions, and then you can finish up the lesson by playing Zero Corners, which is S9 in the Math Card Games book. There is a blog about this game on the Right Start website, so I'll leave a link in the description for you to follow. In lesson 126, we will work with circles. After the oral warm-up, give your student the worksheet, which is 98.1. We will also use 98.2 and 98.3 for this lesson. And then have him or her complete the first problem and then answer your questions that are provided in the lesson book. Whereas in last week's lesson, your student used the small white part of the safety compass that moves independently. In this lesson, we're going to be using the radius arm. Let's take a look.
Okay, so as I said last week, you would put your finger on the center of the safety compass and draw. You'd also have to hold the orange part and draw a circle around. Like so. This time, I'm going to have you put a pencil in the center, and we're going to find the appropriate hole for measuring, whatever that happens to be. The worksheet will tell you what it is. And of course, your paper is going to be taped down, unlike mine. And you draw a circle around like that.
So I think that use of the safety compass is much more like what we're used to using or what we used in middle school and high school with a regular compass. So have your child complete the worksheets and answer the in conclusion questions. For the in conclusion question, we're looking at a dandelion. And while the dandelion is not a perfect example of one dimensional, two-dimensional, and three-dimensional parts, it may still help your child grasp the concept. So then when you're done with the in conclusion question, go ahead and play top and bottom corners, which is S11 in the Math Card Games book. And there is a blog about it on the Right Start Math website, so I'll leave a link in the description. In lesson 127, we will draw the Olympic rings and learn how to enlarge a given model. Have your child read the problem number 1 on worksheet 99 and answer your questions before completing the drawing. Let's look at how to find the center points.
Okay, so the first thing we need to find, we need 3 things. We need to know where the center points go. We need to know the radius, and we need to have a compass. So one way to find out where the center points go for the 3 rings on top is to measure the distance between the ones that are our model, and that's 1 inch. And we've been told that we want to make these Olympic rings 3 times as big. So the center points would be 3 inches away from each other. So we would go ahead and mark the center point here at 3 inches. Now that's pretty simple. So we do 3 inches, and then we would do 6 inches, right? But what about these 2 down here? So there's 2 ways we could do that. We can either measure down and across, or we can just measure the diagonal. So the diagonal is 7/10 of an inch. So from this point to this point is 7/10 of an inch. So 7/10 of an inch times 3 would be 2.1 inches. So we need our T-square. Obviously your paper should be taped down. And our 45-degree angle triangle and a ruler. So here's our triangle and T-square set up where it's going right through that center point. And we just want to measure from here out to here 2.1 inches. So here we have 2.1, and that's where the center point will go for this circle down here. And then of course we can just measure the distance between here and here and multiply that by 3 to get to where the other center point should be.
All right, after your student completes that worksheet, have your child answer the in conclusion questions and then play Division War, which is D12 in the Math Card Games book. In lesson 128, we will be working with area on the geoboard, and we'll learn how to use Picks Theorem. There is a correction. If your book was printed before January 3rd of 2019, please follow the link in the description. Practice sheet 14 has the multivide, which is the warm-up for today. And then let's take a look at how Picks Theorem works.
Okay, we're going to start off pretty simple here. I'm going to just put a rubber band around 4 pegs to make a square. And this square has 4 boundary pegs. Boundary pegs are the pegs that are on the outside of the figure. And there's 2 pairs of boundary pegs. So Picks theorem is a way to tell how much the area is. And of course, on a simple thing like this, your child doesn't need to use it, but it's very useful the more complex the figure is. So if there are 2 boundary pairs, you eliminate one of those pairs, so you can just cover them up. How many pairs do we have? 1. So my area is 1. Let's look at a bigger rectangle here. So how many boundary pairs do we have here? Here's 1, 2, 3. If I cover up one of those boundary pairs, how many boundary pairs do we have left? We have 2. So the area of this rectangle is 2 units, or in this case, 2 inches squared. Let's go a little bit bigger. Now we have internal pegs. So once again, we cover up one of the boundary pairs, and we have 1, 2, 3, 4 boundary pairs, plus the 2 interior pegs gives me an area of 6 units. And of course, this is 6 units squared. Now let's look at a triangle. It's the same method. You eliminate one of the boundary pairs and you figure out how many boundary pairs are left. So there's 1, 2, and sure enough, this triangle has an area of 2. So here's the complete square. That's an area of 1. And then there's 2 half squares, right? So these two triangles put together would make up 1 square. So my area for this triangle is 2. Now I wanted to point out on the worksheet, some people have issues with how the worksheet is written because they're not sure what order to go in. So here you have areas in units on the table, and it pencils in really lightly that there's 1 unit. How many boundary pairs are there? There's 2. There's no inside pegs, so we just leave that blank. That refers to this first square up here. Then the next squares or the next figures follow left to right and then up to down. So this would be the first one, the second one, third, fourth, and fifth. If you're not sure what order to go in, just look at the answers in your book and figure out which figure comes next. It'll be pretty obvious based on the area, and you just need to look ahead. But in the future, just know that we're working from left to right and top to bottom.
Okay, I hope you found Picks Theorem really interesting. I know that I was never taught that in school, and I bet you weren't either. So it's a fun theorem to use, and it's interesting for the students to see how it works. After completing the worksheet and answering the in-conclusion questions, go ahead and have your child play Division War, which once again is D12 in the Math Card Games book. That's all for this week. See you next time. Bye-bye.